Hello, this is a demonstration on using and calibrating a EMC 213 tube tester. It's one I purchased recently. I've just completely serviced it with new resistors and capacitors, etc. When I first got it, it wasn't actually working, and it was just like some of these switches here needed some contact cleaner in them, so that solved the problem there. We'll just have a look inside, so show you what it looks like. As you can see, just a load of switches. There's a few components, resistors and capacitors, and a potentiometer here, which is used for the calibration circuit. And these are high watt resistors, about 3 watt these are, and they're in within 1% of the specifications, so I've left them in. Other resistor here has been changed to a 1 watt one, and the capacitor here is used in the shorts and leakage circuit. This capacitor here is an electrolytic, and it's only used for dampening the meter. You should always change them, as they can always they'll go leaky over the years. So that's a new capacitor there. So that's the inside of it. It's very simple, as you can see. So we'll just go ahead and do the calibration procedure now. And for the calibration procedure, normally for these are just a basic tester for emissions and like shorts and leakages. But for the calibration procedure, we're going to need like a 6V6 valve or a 6L6. All we're going to do is set it up and get this meter to read a 3/4 scale deflection. And I've got the info here. It's for a 6V6. It's D. The filament selector's on 2. These switches down here go to the P position, 3, 4 and 5. And this shunt control wants to be on 31. I'll just switch it on now. It's switched on. So I've tested this valve for shorts before. It's my calibration valve, so we won't go ahead and do that now. But I've got a valve, a 6AF4 valve here, which I will do later. So I can insert that now. Okay. So now it's on the short position. Now put it in the quality position. So now we're really looking for a 3/4 scale deflection. And as you can see, it's gone a bit over. 3/4 scale on here is about 37.5. It's reading about 40. So that's too high. So we're going to adjust that. The reason you want a 3/4 scale deflection is because in the older, this is an analog meter. So you don't want the meter going full scale continually and banging against the stop. Otherwise, you're going to have a bent needle there. So ideally, it wants to be about 3/4 scale. So I'll just switch this off now. I'll just take that one out. And as I said, it's this potentiometer here, which we can vary along with this resistor here. I'll just turn that slightly. Reduce it a bit there. So we can just do the same test again. Put it in again. We'll just check the settings. D, 2, 3, 4, 5. That's on quality. There's another switch here, not N and S. It's always got to be in the normal position. Well, not always. There's some valves you'll get that you put in the S position, but 99% of the time it's in the normal position. So we'll just insert that now. And hopefully we should get it below the 40 mark this time. So I don't want it on 31. As you can see, that's 37.5, so that's like perfectly calibrated there now. So we can take that one out. And what I'll do now, I'm just going to check this valve here. It's a 6AF4 valve. And for this one, the filament volts has to be on D, which it is already. The filament select is on 3. And you're going to have 1, 2, 6, 7 in the P position. But we're going to leave that for now, because the first check we're going to do is going to be the shorts test. So for the shorts test, it has to be in the shorts position. And this, like I said, is in the N position, the normal position. And when we do the actual test, This wants to be on 20. That's for the quality test only. So we can insert this valve here now. As I say, it's a 6AF4 valve. And to do the shorts test, all we need to do is move all these switches here from the K position to the P position one at a time. There's one switch that we don't move, and that's number 3. If the filament select is on 3, we don't move this. If it was on 6, you wouldn't move the 6 position, number 6 switch. But if you do, you don't do any harm. That'll show a light. The tube data manual here tells you that you should get a glow on this neon lamp in positions 1, 2, 4, 6 and 7. So there's number 1. So the lamp's glowing, that's fine. There's no problem. It's not a short. Number 2 is glowing. It's not a short. It's fine. Number 3, so you don't normally move it because filament select switch is in the 3 position. If you did, it's only going to show a short, but it's not to be moved. So try 4. Once again, it should glow at 4. Number 5 is clear. It should glow at 6. It does. And it should glow at 7. And that's it. And there's only it's a 7-pin tube, so that's it. But all the information is in the manual there. So it's passed the shorts and leakage test. So now we can go ahead and do the quality test. And once again, just check your settings before you do the quality test. So the filament selects on 3. Filament volts on 2. This one now wants to go into the quality position. The NS switch is in the normal. And this shunt control here has to be on 20. So now we can put the other slide switches 1, 2, 6 and 7 to the P position. 1, 2, 6 and 7. As you can see, got a reading there. Once again, it's about 37 from where I'm standing, which is an indication of an excellent valve there. These are excellent tests. I've restored it. It comes with a Bakelite case, and I just used some Novas here, scratch remover, to polish it up. The meter is fine. It's a really well looked after test at this one. All the sockets are tight, so it hasn't been used much. Well, thanks for watching. Bye bye.